So 24 years ago, Robert Evan came here from Australia to receive the Marcus Wallenberg Prize for his achievements in the silver-scan measurement system. And today I'm here to talk a little bit what happened since then. So my projects start with the Bio4Energy research program, where RISE have been partnering with many different organizations. Many of the organizations are represented here today. And our partners have been sampling different trees, a lot of Norwegian spruce trees from field trials, and they have been sending the samples to us. And in the wood and fiber properties lab, we take the samples, we cut them to size and polish them so we can measure them from pith to bark using the silver-scan system that I mentioned. So that's a combination of a diffractometer, a densitometer, and microscopy imaging. And I've been working mostly with the microscopy images, trying to extract new research data from the previous projects. And one thing we've been studying is resin canals. And for those of you who don't know about resin canals, that's the structure within the trees responsible for transporting resin in the tree. And it's important for many various reasons: pest control, climate adaptation, chemical composition, and so on. But the problem with resin canals is that they are really hard to detect. They are scattered here and there over the samples, just a few per tree or per annual ring. And they are easily confused with other cell structures or dust particles and so on. But lucky for me, today we have AI. We didn't have that 20 years ago when the silver-scan was built. So to measure the resin canals, I had to annotate a lot of data, resin canals in silver-scan images, and could with that retrain a STAR-DISC 2D model, a type of deep learning, to detect the resin canals in our silver-scan images. But we can't just trust AI, right? So of course we also have to verify it, and to do that, I had to annotate another couple of hundred annual ring images of Norwegian spruce with resin canals. And we could see that it's actually proving pretty decent, and a low estimate is a R value of 0.77 for the number of resin canals per annual ring. But now we have the model and verify that it works. Of course, we then apply it on the rest of our data. So as I said, we've been receiving a lot of samples, over 7,000 incremental cores corresponding to 120,000 annual rings. That's quite a lot. So I took the resin canal data and put it back to the database with the rest of the silver-scan data. And as you see, the timeline doesn't end there, so that's also an invitation for all of you listening today. If you're curious on the resin canal data or the other silver-scan data or any other wood or fiber properties, you're welcome to talk to me later out there. Thank you.